Hello everyone, welcome to today's video. Today we are going to be looking at a static simulation of this concrete block machine frame, okay? So a static simulation basically means that we are going to try to load this frame with a given weight, then see how this frame will respond to this weight, okay? So what we aim to see is that we aim to check the deflection, okay? The deflection, how much this frame will deflect or bend when we apply a given load. And we also aim to see some of these components, how they respond when a load is applied. So with that said, we shall also compare what happens when we remove these gussets and we have another frame here without the gussets, okay? So we shall compare the results from this frame and the results from this frame with the gussets. So in order to do a static simulation, we shall go to Solidworks add-ins, then we have to click Solidworks simulation, okay? Then this will appear. When this appears, you click New Study, we select Static, we click OK. Okay, after this, we see that all these dots here, they mean these are the joints, okay? These are joints. The interaction is bonded, so that means it takes these frames as if they were actually welded, okay? So that's okay. Then we shall apply the load. So we're going to first apply the material. Go to apply material. So when I checked the list here, we never had mild steel, so I put mild steel here. I created mild steel. When I searched online, I managed to obtain the values for elastic modulus for mild steel, which is this, and I put it in. Poisson's ratio, which is this, and the mass density, and also we had to put the yield strength. Then we have this heat capacity, which is not actually useful for static simulation. So with this, we are going to click apply, then the material will be applied to the frame. Then afterwards, we are going to apply fixtures or fix. We're going to fix these joints at the end. So we go to joints, click this joint, that joint, this one and this one. Then we go here to the symbol. We are going to analyze these symbols so that they can be visible. Then click OK. Then afterwards, we're going to apply a load, okay? We're going to apply a load on these joints here. Go to this, click joint, click on these joints here. Then the direction, we shall click on this face. Then we are going to add a load here. So we're going to add a load in the Y direction. So we're going to apply a load of 500 newtons. 500 newtons is an equivalent to 50 kgs. So this means that we're going to apply 100 kilograms on this frame, okay? So 500, we see here we have 500 newtons, and we have selected per term. This means that we're going to have 500 newtons here and 500 newtons on this joint, which is a total of 100 kgs, okay? So with that said, we're going to first enlarge the symbols here. We enlarge these symbols so that they can be visible. Then click OK. So we have finished applying our load. Then we shall go and apply a mesh. We shall just put in the middle there. Click OK. So it is applying a mesh to all the components. So it has meshed up all the components, and we are going to then run the study and see our results. Okay, it has finished running the study on this frame, and what we see here is that we see how the stresses have been distributed on the this is stresses, and the stresses are being distributed on the gussets on the frame. So we see here, we can check for the displacement. We see that we have a maximum displacement in the middle, which is actually what we expected, because when you put a load here, we shall have more bending in the middle compared to the sides, okay? And on this stress part of it, we see that we have maximum stress here. which is around the gussets. Okay, then for the strain, we see that we have maximum strain here. And so what we are looking for here is just displacement, the amount of deflection what this frame. So to see that, we are going to check. We're going to check Simulation Advisor here. We'll go to Results. So we see that when you apply a weight of 100 kgs on this frame, we see that we have what? A deflection of about 1.6 millimeters or 0.016 meters, okay? Which is actually fairly a good number because, as I said, 100 kilograms is a lot of weight. So as I said, we are going to compare the frame with gussets and one without gussets. So I have another static simulation that I did here of this frame without the what? Without the gussets, and let's check the results and see. So from the results, we see that we have actually the number is nearly twice as much as without what? You see, we have 0.02 meters deflection, which is nearly twice the other one. Okay, so we see that the gussets actually play a major role in restricting the amount of what? Stresses, and also the deflection is actually less compared to what? One without the gussets. Okay, so some other things we can do on this frame here to make it stronger. We have seen that the gussets actually make the frame stronger. We can also change the section and maybe use another section, or we can have a thicker section, okay? Because this square pipe is only about 30 by 30 and the thickness is 2.6. We can use 35 and see, and yeah, it will be better. Okay, so a stronger frame, if we have this larger pipe, maybe a larger section, this means that our machine will actually last longer. Okay, and these gussets here, we have seen that they take up the stresses, so this will help us have a longer life for our machine. Okay, yes, because as you're using this machine, you have to apply a weight here. That's why we did the simulation by applying a weight on this machine. Okay, so with that said, I think this is the end of the video. So yes guys, thanks for watching, and I hope to see you guys in the next video.